A3. Right. So here, what we have is just simply, drawings of, the hydrogen atom in different charge states, right? So you have hydride, right, which is H minus. And so, right, that's the 1s2 configuration. You have hydrogen, which is just simply, right, the 1s1. And then you have, what's typically referred to as proton, right, which is H plus, which is just simply, the radius of a proton, right? And so, when you go into acid base chemistry and you're thinking about all of that, unit, and when we're talking about protons, we use that interchangeably with H plus because they're the same thing, because hydrogen, right, doesn't have any, standard hydrogen doesn't have any neutrons, it just has a proton and an electron. And so if you remove that electron to make H plus, right, all you're going to end up with is a proton in these cases. And so looking at, these sizes, we can use, our thinking about ionic radii and how charges affect the radius of, the atom or the ion, right? And so as you add more electrons to a system, right, you would expect the ionic radius to increase, because not only are you adding more electrons, and that's what the radius really is of an atom or an ion, is really just the electron density. So that's going to increase from that, but it also the Z effective, right, is going to go down for both of those electrons. So that, that one proton in the case of the hydrogen, right, beforehand it was only really pulling in one electron. All of a sudden, that one proton has to pull in two electrons. And so if it's trying to pull in both electrons, it's not going to be pulling in, both of them as strongly as it would if it was only one of them. And so that's going to allow them to kind of, move a little bit further out in those cases. And so you'll end up with a larger ionic radius. And so looking at, and, same thing when we go the other direction, right, where we were talking about, positively charged, if you remove an electron and all you have is a positively charged, nucleus, right, you're not going to have any electrons around it. And so you would expect the radius of that ion to go down. And in the case of, a proton, all it is just going to be the radius of a proton, right, of H plus in that case. And so, looking at this right here, the smallest one is this guy. So we can expect that, right, to be the proton, right? So H plus, right? And then here between these two, right, one of them is 1.3 angstroms, the other one's 1.1 angstroms, right? The 1.3 angstrom is the one that we would expect to be the hydride, right? And then the 1.1, right, is we would expect to just simply be hydrogen atom in that case. So, right, and so this, again, it just goes back to thinking about Z effective. It goes back to thinking about how the nucleus is actually interacting with the electrons, right? They're not all just simply on their own. And that's it. That's everything that everybody voted on.